Um, time. Time to do some materials. Alright, I want to start. So I got my unit test working. I can use all my synchronous function, or I can use all my functions synchronously now. So the only thing left here is I need to write some async wrapper stuff and be able to put these in some promises and generate some events from the results to tie into. But that's a whole nother can of worms that I probably won't start till later on in the week. So now I'm going to kind of decompress and do something a little bit more fun, which is, for me, just fucking around with some materials. So here we go. I saw a trick just now that allows you to make a normal map from noise, which is very interesting to me. I'm going to try that. I have some tutorials in mind that I want to try out. So, let's create. Just thinking about where I want it. Maybe in here would be okay. We could just go ahead and we'll call this empty normal from noise. I found something interesting here. Oh yeah, dude, that's sick. Very nice. I like that. Neato. Alright, well that should do for what I needed it for. Huh. Cool. That's just really cool. I like that a lot. So you can just kind of make cool little bumpy surfaces out of the straight up noise functions. And the fun part about this is it's distortable. So if I just create another one, and then now we get something a little bit cooler like this, right? Pretty fucking neat, actually. Pretty neat, actually. So then we could just okay, so now I want to get into the, so I needed somewhere to get a normal map from. We can do it like this, so I think we're good. Just to see what it would look like without that. Looks like this to this, and we could also doesn't seem to make a difference. Fair enough. Fair enough, fair enough, fair enough. Now I'm just doing wacky shit out of curiosity. Okay. Alright, so let's do some parallax occlusion mapping. I gotta pull my tutorial that I was gonna look at up. Where did it go? Fuck.
Complicated.
Oh, I'll get you later. Yeah, perfect.
My diffuse, my height,
Okay.
and my normal. And now I'll go properly organize and lay these out. So first of all, the height texture will have to go over here and connect up to the height map texture. Then diffuse texture will be able to go here and connect directly into your base color, and your normal will connect directly into the normal. Now the UVs of these nodes will have to be offset by that parallax occlusion mapping effect, So the UVs will go to the parallax UV output of the parallax occlusion mapping node. So we'll connect it up something like that. Now you'll notice that our height texture won't actually connect to our height map texture here, because this height map texture is looking for a T2D, a texture object, whereas this right now is a texture sample, not a texture object. To convert a texture sample into a texture object, right-click on it and convert to texture object. By doing that, my height texture now becomes a texture object, and I can successfully plug it in to our height map texture here, which is defined as a T2D or a texture object. The next thing we have to do is define what channel of this texture are we using for height. So I'll drag this out and create a constant 3 vector, and I'm just going to use the red channel. So for X or for red, I'll put 1. Or you can just choose a color red, and that will use the red channel of this texture for height. We'll also have to define a height ratio, and you can see here that this is how deep the height map is in relation to its width. So it says typical.
Oh, this has to be a texture, huh? Okay, that's fine. Luckily, we have noise. So I'm just trying to transform this into the same space as the noise that was generating a viable texture. There is some normal information going on here. Yeah, okay. It's doing stuff. Yeah, we're getting some kind of chunkiness here. Let's actually work with sphericals. No. Oops. So now we can chain distort. Okay. It doesn't look too bad. I mean, obviously all the artifacting and shit looks bad, but it's doing a thing. Why am I multiplying by 1? Alright, well, anyway, let's do this. Okay, great. Now let's continue with this. So, height map channel v4. No. Oh, I see. That's a little bit more unfortunate. Hmm. 8K.
Local values are between 0.05 and 0.1. I'm just going to set that to 0.1 to give us a bit more of an extreme effect. Oops, not 1.1. There we go. Now, once we've set this up, there's a few other things we have to keep in consideration. First of all is the min and max steps. These are quality settings. If you have too few steps, you'll notice that the surface will look like it has almost slices or cuts in it. So if you run into that effect and you're wanting to resolve it or try to make it appear a little bit better, you may have to modify your min and max steps. So for now, you can see the default for min steps is 8, max steps is 32. I could drag these out to constants and put in custom values. And I would recommend making all these nodes that we're adding parameters and using this as an instanced material if you're going to be reusing it in your scene. But for now, we're just going to type in the values and hard code them in. So maybe for min steps, I'm going to do something like 16. And for max steps, instead of 32, I'll do something like 64. So I'll push the quality up quite a bit. And that might not actually be needed. So you might want to preview how things look before you start changing those settings. Now, the next thing that we might want to have on this surface is shadow support, or have shadowing be enabled. So there is an option here for rendering shadows. Do you want shadows to be rendered on this surface? And we probably definitely want that. So I'm going to create a Boolean parameter here, and I'm going to check it as true.
The fuck is going on with my display?
Shadows, and then we'll have to define.
Hold on. The fuck? Is like the plug loose or some shit? Technical difficulties.
Find a number of shadow steps.
Okay, we're gonna be able to use my computer.
16. I'm gonna make that 32. So I'm gonna go in here.
All right.
32. And then you also have your shadow. Penumbra, which is how soft or sharp the shadows are. And I'm going to take that and just leave it at 1. So now we have
while that's building, we can...
Shadowing enabled. The only other thing we need is a light vector, the direction that the light is coming from that generates the shadow. Now, the best way to do that, you can put in a value that describes its direction, but probably the easiest thing and probably the quickest thing to do is to drag this out and use the sky, atmosphere, light direction. And that will automatically get the light direction of any directional lights in your scene.
Sky, atmosphere, light direction.
And you have a number here to define which index or which light it is. So if you only have one directional light, then it's going to be 0, and that will be the only directional light you have in your scene. If you have multiple directional lights, then you may have to change this number to specify which directional.
I see. And then you got this. Ooh, what's going on here? That's kind of neat. Interesting. Doesn't seem to be contributing too terribly much. Oh, wait, no, there it is. Okay. It's kind of cool. Oh, now that's neato. So that's pretty cool, actually. I just wish that I could use. I just wish that I could use the output of like the texture functions or the noise functions for the height map here. Is there a way without having to like in real time without having to like bake it? Because like I could obviously bake it to a texture, but that's not exactly what I'm talking about. So yeah, now I see what's going on. There we go. Now we're getting some cool little effects there. Almost looks like trees. Almost. Pretty cool. Pretty cool shit. I'm not entirely sure how I should use it yet, but I did want to play with it. Can add like some interesting depth of field shit to thing. Hmm. Kind of fun to just play around with it, right? Hmm. No, it's not gonna do anything. kind of wild. It's kind of cool, honestly. Hmm. Pretty neat. This seems like it could be a pretty good answer for like planet surfaces potentially, assuming I can get the texture object I need for it. So, um, in UE5, is there a way to get a texture from a sample? No. That's not exactly what I meant, but you just can't handle it. I think some work better than others. Neat. Still not entirely sure this is useful to me. I mean, it's useful. I'm just not sure that this is going to be better than just doing displacement with nanite. What was the other thing that I wanted to look at? There was several. This place has a lot of tutorials.
Like if I save this and I look at this actually applied to our object in the scene, it doesn't seem like there's really anything wrong. And if we look at this sphere and we push it into the ground, you can see that pixel depth offset effect is now working, where these details in the ground are actually cutting away from the ball properly and not just being like a flat surface. So everything here is working as expected, and it looks pretty awesome. It actually looks like a very detailed surface. But if you do notice on certain shapes, let me move this a bit higher up as well. There we go. But if you do notice with certain shapes and you apply your parallax occlusion map, if you're getting weird shadow artifacts, you might have to take your surface that you're doing the parallax occlusion mapping on and go into the static mesh component and disable cast shadows. So if you're using, you see here, cast shadows is off, and that's on this plane. If I turn it on, there we go.
Alright, that's enough for that. I want to see this.
Complicated. So to make the lighting better, what we're going to do is go to the mesh rendered is made up of by going to the emitters. In this video, we'll take a look at how you can create 3D volumes from multiple 2D images in Niagara in Unreal 5.2. Also take a look at a new feature in Unreal 5.2 called heterogeneous volumes, which will allow volumes like smoke to have full lighting interaction with
oh shit, this is 5.2. I'm in 5.1. I gotta wait for that to release, at least until I complete my C++ rewrite shit.
In this video tutorial, we're going to take a step back from side distance fields and take a look at how we can ray march a texture in depth using HLSL. This can give us the possibility of making so many interesting effects like what we see here, giving us the illusion of depth, really when it's all just being mapped on a simple flat plane. Let's take a look at how we can create this effect in Unreal using HLSL. So to begin, we're just going to create a brand new material. So I'm just going to go in here and right click in my content browser and go to Materials, Material, and I'll call it Ray March. And inside that material, we're going to create a brand new custom node and connect it up to a emissive color for now. And I can give it a name if I want, but I'll just leave it as the custom node. And then what we're going to do is type in some code to start setting up our texture, or a custom texture that we're going to want to plug in and Raymarch in depth. So to type this code, I'm just going to jump on over into Visual Studio so we can see the code a little bit easier. And to pretty much start doing this, the first thing we have to do is pretty much set up our Raymarching. So I'm going to create a float3 variable called RayStep and just make that equal our view direction times -1. And then what we're going to do is create another variable, but this time a float4 called input text or input texture, and that will equal a texture 2D sample. And that's going to allow us to create pretty much a texture object or a texture node to some extent. If you think about Unreal and you think of a texture sampler node, this is pretty much what we're assigning to this variable. And inside that kind of texture 2D sample, we're going to need our texture object, the information of the actual texture, and then our sampler, so texture object sampler, and you can name these whatever you want. It could be text object, it could be text or tmap or whatever you want to call it, as long as they're both following that name. So if I were to change this to like text, then this would have to be text sampler. But in this case, we're just doing text object, and that means this has to be text object sampler. And then what we have to do is define the UV coordinates or the UVs, so I'll just type UV, and that is pretty much it. That gives us now a texture that we can load in and store as this variable. So now we have our RayStep and our texture. So the next thing that we want to do now is do a bit of a for loop so that we can step through in depth and draw these Raymarch textures at different depth. So what we'll do is say for, and we'll do int I equals 0. If I is less than 25, I plus plus. So right now I'm just doing 25, which means 25 slices. It's going to loop through this 25 times and create 25 individual texture slices in depth, and that will pretty much be how many times this texture gets duplicated in depth. If I want less slices, I could just change this number here, but I think 25 will be a good amount to give us some good distance and to make it look pretty solid and not have too many gaps in between it. So then I'll open up this loop, and what we'll do now is we'll check this texture. So we'll take a look at this texture, and we're assuming that this texture is going to be a black and white mask, where maybe the white areas are the things that keep the information, that actually draw the slice, and anything that's black in that texture or below a certain value in luminance or brightness will just end up getting kind of clipped away. So what we're going to do to mask out brighter luminance or higher values is we're just going to do if, and then we'll take our texture here, input text, if the red channel is greater than 0.1, and if the blue channel or green channel is greater than 0.1 and blue channel is greater than 0.1, then what we'll do is return a color. And I'm just going to make it red. And I'm going to use I variable for the red color. That way, when each slice gets drawn in depth, it's becoming brighter and brighter in red. So it gives us a bit of a grade to the times 0.15. Now, what this 0.15 value is pretty much just going to be like a multiplier for the distance in between the slices. So if you want more distance or more bigger gaps in between these 25 slices that we're drawing, you will have to increase this value here. But I think 0.15 should give us a good distance for now. But that's how you would be able to adjust the distance in between each slice that it Raymarches in depth. And then finally, we'll have to take our texture again, so input text, and we'll make that equal our texture 2D sample, use our texture object, which we'll talk about in a little bit, and then we'll do our texture object sampler. So pretty much the same thing we did up here. The only difference is the UV now is not just going to be UV, it's going to be UV but only in X and Y, like that. UV.xy. Work real. These and all this is our illusion where it has those slices drawn in depth. So this is really cool. And if we go in here, just to go over a little bit of a tour of changing things around, if we made our for loop not I is less than 25, if we did I is less than 5, well then we only get 5 slices in depth and then it stops. If we do I is less than 50, then we're going to get 50 slices in depth. And if we see right now there's a good sized gap in between those slices that we're drawing, if we want to make that gap smaller or larger, again, we'd modify the UV plus ray step multiplied by that multiplier that will change the gap in between there. So if I did multiplied by 0.15, which is what we currently have, we get that. If I do ray step multiplied by 0.1, well, then we're going to get a smaller distance. If I do ray step times 0.025, then we have a really small gap in between those slices, and from far away it feels way more solid. Now you can use this effect for so many different things, but it gives us a really cool illusion where even on a flat surface like this ground, it can give the illusion that there's some sort of hole or indent into the ground. So there's a lot of flexibility to create some really interesting illusions with these kind of ray marched textures in depth. They're totally a camera trick, but they allow you to do some really fun things really easily. So we'll take a look next in our upcoming videos of how we can add some animation where each slice
Pretty
of
neat.
this ray marched.
I'm feeling kind of nappish, to be honest. So I think I'm gonna go take a nap. I was able to do what I set out here a little bit faster than I thought, which was really just to get the parallax occlusion mapping node working. I get it now. Also figured out normal maps from noise. Alright, later.